So something used in a lot of algebra classes are algebra tiles, and they are kind of a hands-on tool, and this is just a visual picture of what they look like. What they basically are tiles, like they're called. They're little plastic things where each one represents something different. And the way they kind of come about is it starts with this one up in the corner. This one that I'm kind of circling here. This is called the unit tile. And the reason it's called a unit tile, some people call it the one tile, is because if you were to measure the sides of it, it is 1 square wide and 1 square long. So a 1 by 1, if you could do 1 times 1, that's an area of 1. So we have what we call the unit tile or the one tile. These other tiles are much more complicated. If I tried to measure this next tile, it's 1, 2, 3, and a little bit, 3 point something long. So if somebody came around and said, well, measure it, how long is that tile? You'd probably actually have some trouble saying, well, I think it's 3.4 units long. And then somebody else might say, oh, I think it's more like 3.6. Well, it's kind of hard to say exactly who would be right, 3.6, 3.4. So instead, what we do is we say, it's kind of unmeasurable. We can't get an exact measurement. So we're going to say that it's x long. It's got some distance, it's x long. So the same story goes for this next tile, this long purple tile. It is 1, 2, 3, 4, 5, and a bit, if you look real closely. So someone could say it measures about 5.2, 5.3, 5.4. And so what we're going to say is it's a distance. I'm not going to say x, because x represents this tile. I'm going to say it's a distance that I'm not sure about, so I'll call it y. So we have these three really crucial tiles. We have the unit tile, that measures 1 square long. We have the x tile, which measures x long, it's unknown, and we have the y tile, which measures y long, which is also unknown. So we're going to take these three tiles, and we're going to develop a couple more tiles that we can kind of give a name to. And we're going to start with this big blue one down here. This is what we call the x squared tile. And the reason for that is because if you were to measure this side and this side, they are both the length of x. So this is x long and this is x long. And an x times an x makes an x squared. So we have what we're going to call the x squared tile. Then we have this big ginormous purple tile, and this big purple tile we often call the y squared tile. And it's just for the same reasons. If you were to measure how long this side is, you'd say it's probably y long. And if you were to measure how long the bottom is, you'd probably say it's y long. So it's a y by y square. And a y times a y is a y squared. So that's where it gets its name. The last tile is kind of unique. We call it the xy tile. And that is because if you were to measure it, it actually turns out that the bottom of it measures y long, and the side of it measures x long. So it's an x by y tile. So hence the name xy. And so these are the different tiles that we work with in our classroom. We have the x, the y, the x squared, the y squared, the xy, and the unit tile. And so to give you some examples of some simple ways to use these tiles, here's a picture of a bunch of tiles that got spilled out on the table. And they're not colored in, but they're the same tiles as the previous screen. And I'm going to ask that we practice writing an expression. So an expression is kind of a list of the tiles. Let's write an expression for what we have on the screen here. So this is what I'm thinking. Let's go through and name each one. Now this big purple square, remember that's called the y squared tile. These blue ones were called the x tiles. And these little ones are called the little unit, the one tiles. So we have a y squared tile. Plus, how many x tiles are up there? Well, there's 1, 2 x tiles. So I'm going to say plus 2 x tiles. Plus, how many units do we have? We have 1, 2, 3, 4 units. So 1, 2, 3, 4 units means plus 4. There is my expression. We have a y squared plus a 2x plus 4. So you try one. Write an expression. Pause the video. Write an expression for this. Okay, so here's my answer. This big one looks like an x squared to me. This looks like an X, this looks like an X, and these two little ones look like unit tiles. So my expression is going to have an x squared tile, plus I'm seeing two x tiles up in the picture. I see 2 x tiles, so 2 x's, plus I see 2 units. There it is, that's my expression, x squared plus 2x plus 2. Now the reverse of this is going to be, you're going to open up your math book and you're going to see problems like this. Simplify this expression. And you're going to see this, a bunch of different things. 2x plus 3 plus x squared plus 2x. Well, here's a strategy. When you see this, think of the tiles. When you see 2x, what does that really mean? Well, that means there are 2x tiles. So I'll draw them. When you see 3 here, well, what does that mean? Well, that means there are 3 little units. 1, 2, 3. When you see x squared, that really means there's one of those big x squared tiles. One of those big blue x squared tiles. So here's that big blue x squared. When you see 2x, that means you have 2x tiles. I know they're not drawn very nicely, but it doesn't really matter. What you want to do is you want to look at it and simplify anything that could go together. So this is what I'm noticing. I see 2x's here, and I see 2x's here. Why not put them together? Why don't we say that we have 4 x's all together? Plus we still have these 3 little units, so plus 3, plus we still have this big x squared tile. And none of those tiles match, so we're not going to simplify them together, and we're going to say, you know what? This is the simplified answer. There's really 4x tiles plus 3 units plus x squared. So now you try. Simplify this thing. X plus 2y plus x plus 3 plus x. Okay, so this is what I'm thinking. We have an x tile. We have 2 y tiles. Now the y's are the long purple ones. So here's a y, here's another y. Plus we have an x tile. Plus we have 3 units, so 1, 2, 3. Plus another x tile. So let's simplify this answer a little bit. What I'm noticing is that there is 1, 2, 3 x's all spread out. 1, 2, 3 x's. So why don't we write 3 x's? Plus, now that those are gone, we still have these 2 y's. I don't see anything else to combine them with. So plus 2 y's. Plus, I still see these 3 units, so plus 3. And there's my simplified answer. 3 x's plus 2 y's plus 3's.